You're listening.
Yay. So
Exponents and division.
You sounded like the lady who speaks the episode titles.
Exponents and division.
Can you underline the N all the way? It's not right.
Nope, I'm gonna purposely leave it.
Oh wow, you're gonna be like that.
When
Don't make Evan more salty. Please.
dividing powers with the same base, yesterday we multiplied, and what did we do with our exponents? Added the exponents. So if we're dividing, we're gonna what? Subtract the exponents. I'm gonna do some examples. Let's say we have m12th divided by m to the 5th. Okay, you have to check. They have to be the same base, just like yesterday. You know how that was very, 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 very important. Do they both have the same base?
Yeah.
Yes. What is my base?
M.
M. Don't change that. Subtract it. So top minus the bottom. So what's 12 minus 5? 7. Okay, let's try another one. We have 7 to the 5th power divided by 7 to the 2nd power. What's their common base? 7. Don't change that. 5 minus 2 now. 3. So that would be 7 to the 3rd. Tim, shut your computer, please. Are you doing notes? Okay, that's fine then. Okay, let's do one more. Shh, quiet. W to the 8th over W to the 5th. What do we got? W to the 3rd. Good. Okay, so far so good, right? All right. All right, let's talk about 0 exponents. Okay, and I'm going to leave a space here because I'm going to write something in words, but I'm going to do a little thing to maybe make you understand it better. I'm going to talk about the number 3. What's 3 squared? What's 3 times 3? 9. Okay. All right. So 3 to the 3rd would be 3 times 3 times 3. What is that? 27. Okay.
27.
Oh, sorry. Thank you. I don't know why I wrote a 4.
24.
I don't know why.
She said
I said 27 and wrote a 4. I have no reason. Okay. Well, what's the relationship between this 27 and this 9? What's happening there? Multiplied by 3 if you go up this way, right? So if you go this way, instead of multiplying by 3, you're what? Dividing by 3, right? Okay, so what do you think 3 to the 1st power is going to be? 3, good. Because if I take 9 and I divided it by 3, I'd get 3, right? Okay, interesting. Well, what happens if I get 3 to the 0 power? It would be 1, because 3 divided by 3 is 1. So 0 exponents, anything to the 0 power is 1. Anything. So you could say 100 to the 0 power, your answer is 1. You could say 756,432 to the 0 power is 1. You could say x to the 0 power. What is that? 1. No matter what, anything to that 0 power is 1. Okay? So let's try a couple examples. All right, the first one, we have -8 to the 0 power. What is it? 1. Perfect. Let's try another one. Let's do 3m to the 0. Ooh, let's break this apart. What's that 3 doing to that m to the 0 right now?
Oh, wait, that's being
Multiplied, right? So I have 3 times m to the 0, but m to the 0 is really what? 1. So this is just 3 times 1, which is 3. So you have to be careful because you have to think, is that a coefficient? Is that getting multiplied against it? Okay, that 0 power is only on that m. Okay, one more. Let's try another one. Then I'll answer a question. What if I wrote it like this? Then what?
Then would this one be what?
This one would be what? It's saying that junk in that parenthesis is raised to the 0 power. Anything to a 0 power is what? 1. So this one's 1. Because that whole thing is being raised to that 0 power. So do you see the difference here?
So it eliminates the n? Yes or no?
Anything raised to a 0 power is 1. Yep, and it doesn't matter what that junk is, it's 1. Okay? Yeah, I refer to it as junk. Mathematical
What
terms.
was the eyebrow raising link?
Because it's super mathematical.
I'm uncomfy.
You're always uncomfortable.
Yes. All right, negative exponents. Let's talk about negative exponents. And I'll make sure to make this line.
Are you kidding me? I'm gonna cry.
Negative exponent. We
I'm not done reading.
do not, can't even stress the not enough,
Write it in red.
want negative exponents. We do not want them. So we have to change them so that they're not negative exponents. Okay, I'm going to teach you how to change them. We're going to go straight to examples. Okay, we have 3 to the -2. Ah, red flag.
That mean the
I don't want a negative exponent. Oh no. Okay, so this 3 is very unhappy upstairs. If he's unhappy upstairs, what we're going to do is we're going to send him down to the basement.
Oh, he's being a victim.
If he gets sent down to the basement, he's happy because he's alone. He doesn't want to be around anyone. So he is now a positive exponent. The only thing that changes is the sign on the exponent. When you move them upstairs and downstairs, the only thing that changes is the sign on the exponent. Well, I need a placeholder up here.
1.
A 1, perfect. Beautiful.
Wait, can we put any number on?
What's a good placeholder that's not going to change anything?
1.
Multiplying by 1, right? So 1. Yep.
Oh, 1.
So now is your exponent happy? Yes.
Why are you talking like
Okay.
this, like
Let's try another one.
your lung is out?
Not sure.
Let's try another one.
Not sure. I'm not negative.
Let's do y to the -6.
Can you stop?
That y is so unhappy. Where should he go?
Basement.
Down to the basement. Okay, the only thing that changes when you go upstairs and downstairs is the sign on the exponent. And what goes on top? A 1. Good. Beautiful.
Not sure.
And what would you do? Would you just write this?
1 over the, yeah.
Yeah, that's what we're doing.
You're just gonna like 5 questions and answer.
Okay, so
And I didn't show my-
this number is very different than y to the 6th. This is a very, very tiny, tiny number. Okay, we'll do an example. So Riley's asking if I had like 2 to the 3rd and 2 to the negative 3rd, are they the same thing kind of essentially? Like, why can't I just do 1? This one, he's on top, right? 2 to the 3rd. Well, what's 2 to the 3rd? It's 2 times 2 times 2. Well, what's 2 times 2? 4 times another 2, 8. So the answer for this one's 8, right? Now this one, he's not happy upstairs. Where does he need to go? Downstairs. What goes on the top then if he's downstairs? A 1. Oh, what's 2 to the 3rd there? What's 2 to the 3rd? 8. So this is 1 over 8. 1/8 compared to 8. Do you see how that's a huge difference, right? Okay, good point.
I thought that he was asking like, do you have to write?
You don't have to talk about the base, but you just have to know about it.
You just have to like.
Yeah.
You just write the answer. That's what I thought he was asking.
Oh,
Okay, let's try another one. -2, guys, you need to stop talking, to the -3rd power.
what's
What does that mean?
it's dead.
Where do we need to send them?
Downstairs.
To the basement. What's the only thing that changes when I put them downstairs? The sign on the exponent, and there's a 1 on top. Good. If there's nothing already on top, we need to put that 1 there because it needs to be a placeholder. So the only thing that changed was the sign on the exponent, not on the number. A lot of you are going to want to try to get rid of that negative in front of that too. That is not what changes, only the sign on the exponent. I do all the time. Okay, let's keep working this one out. I can figure out what -2 to the 3rd power is. That's a -2 times a -2 times a -2. Well, let's figure that out. What's -2 times -2? +4 times a -2, -8. So this would be really 1 over -8. So if you can simplify your numbers, you're going to have to do that. Yes. Unless it specifically says to write it as a base and an exponent. So sometimes it'll be like 7 to the 22nd power. I don't want you to do that because that's going to be a ginormous number. Okay, so if we went back and we looked up here, could I simplify this one a little bit more? Yeah, what would that one end up being? 1 over 9. Yep, 1/9. Okay, but can I simplify the y to the 6? No, because I don't know what y is. Yeah, exactly. Okay, so let's try just a couple more examples. We're going to try to combine things that we learned yesterday and stuff we're learning today. So we have 4 to the 3rd times 4 to the -5th. Okay, you tell me how you think we should solve this. Okay, you want to start with this guy and do what with him? Throw him in the basement. Okay, let's do that. So I have 4 to the 3rd. Don't move him because 4 to the 3rd's happy, right? He doesn't get punished just because he's unhappy. He can stay upstairs. Okay, but this guy, he's unhappy. Let's put him down in the basement. Now his exponent turns positive. Okay. Now, what did we start learning at the beginning of today? If you're dividing and you have same base, you subtract your exponents, okay? Well, top minus bottom would give me a -2. So I'd have 4 to the -2. Oh no. Now what? I have a negative exponent. That's not allowed. Throw them in the basement.
Throw him away.
Okay, am I done? No, why? I can simplify that. What is 4 squared? 1/16. Good. Yep. Now, that was one way to solve it, right? That was one way to solve it. Maybe somebody else thought, hey, I know my rules from yesterday. If I'm multiplying and I have the same base, what do I do with my exponents? Add them. Oh, hey, look, there's the same base here. That's a 4. Well, what's 3 plus -5? -2. Oh, hey, I know I don't like negative exponents anymore. Throw him in the basement. Am I gonna get the same thing?
Sure.
Sure am. Is either one of those wrong?
Other boy.
No. Two different ways to approach the problem, right? So someone sitting next to you could do it completely different than you and get the same answer. That's the beauty of math.
Maybe we should probably come-
Okay, one more example on this stuff and then we'll start on our assignment. What happens? Oh no.
Can you bring him upstairs?
Yeah, he's not happy downstairs, is he? So where should he go?
Upstairs.
Upstairs. So he's gonna go upstairs. Now, do I really need to put 1 times that anymore?
No.
No, because that's not gonna change anything. If there was a 3, then you'd have to put that 3 there, okay? And so he's happy upstairs, so he's good. He's done.
Yay.
Yay.
Oh, I'll draw them when they're upstairs.
Teamwork.
Okay.
What?